Now that we have looked at what we do when the system call fails, let us look at where we actually add a system call implementation, and that is in kernel slash sys.c. This is a very large file that has all the system call implementations, and you can see this is an example system call that takes one input. And the reason I clipped it is that it has comment in Swedish, so you'll find if you speak any language other than English, you might want to search uh, for things in the kernel, which is you'll find lots of hidden gems. But anyway, this is the get PID system call, the implementation that I was just talking about a while ago. And since it takes zero inputs, then it uses syscall underscore define zero, get PID, and then it returns the current task's process ID basically. And this is the get thread ID. This is again another system call, and these are basically get user ID, system call, which is basically returns the current user's ID because every user has an ID on the system. So system call handler is a user space, is what happens when basically the user space application signals the kernel that they want to execute the system call. This is basically your system call procedure. The system will switch to kernel mode, and then there's only one single mechanism for the user to signal to the kernel that he wants to access now the kernel mode, and that is using a software interrupt. And the software interrupt basically incurs an exception. The system will switch to the kernel mode and execute the exception handler. And on x86, this is a predefined interrupt hand number, which is 128 for all basically system calls. And then a lot of how this handling happens is architecture dependent, and you do not need to worry about it. Basically, the flip between from user mode to kernel mode is basically architecture dependent. And yeah, as we said, we are not going to do any architecture dependent work in this course. There are many mechanisms for system calls.